Hey, this tutorial is on solving equations using algebra. So previously we've been using manipulatives like tiles and scales and things like that. So now we're going to take off the training wheels and solve equations using a system we're going to call algebra. So let's look at that scale idea first. And the cool thing that I like about the scale idea is you have an equation, you can model it, and you can actually see what's happening with this app. With this app, it will actually record the steps just like as if you're doing algebra. And I'll show that to you in a second after I have this modeled. 2x minus 1 equals 5, 3, 4, 5. It balances out. Continue on. We've learned that we first want to isolate the variable. I'm going to go over these steps again, but right now we have a little red balloon here, -1, that's ruining things. I don't have x by itself, so I'm going to add 1 to both sides. And watch what happens in the little box up here. It creates a new equation, and that's what's going to happen when we do algebra. When we write a system of simplifying the equation until finally we get to the simplest form, which will be x equals something. And that first step was done, so now I have 2x is equal to 6. And 3 of these go with each x. In other words, if I divide both sides by 2 and hit go, I'll get my answer. So here was our first, the equation 2x minus 1 equals 5 was simplified by adding 1 to both sides. So we got 2x is equal to 6. It was simplified even further by dividing both sides by 2. And now we get x equals 3. So that's what we're going to do when we do it ourselves with algebra. We're not going to draw tiles. We're not going to draw scales and balances and things like that. We're going to use what we learned from that to solve equations. Oh, that's zoomed. Okay, so here is what you need to do when you're solving equation, the type that we're presenting today, which is exactly like this. 2x minus 1 equals 3, or something like that. So we're going to take that example and have a look. First off, let me get in here, get my pen going. Oops. Hang on, let me pause. Okay, so we have 2x minus 1. The first thing we want to do is isolate the variable. The variable is x. Right now, we have 2x. That's okay. We're first going to isolate that variable, get it down to 2x, and then we can simplify it in step 2 even further. Right now, there's something that is in the way. We don't know what 2x is. We know what 1 less than 2x is. So what we got to do is undo that subtraction, that subtracting by 1, and so that we will end up back at just finding out what 2x is. I don't want to know what 1 less than 2x is. So I'm going to go ahead and show you the way I do that. Isolate means get the variable by itself. So we're going to add or subtract from each side, from both sides, because remember, think of it as a balance on the equal sign. What you do to one side, you have to do to the other side, or you'll disrupt the balance. So here's what I do. If I subtracted 1 from 2x and I get to 3, I'm going to want to undo that subtracting just to figure out what 2x is. So instead of subtract 1, I'm going to add 1. So subtract 1 you can think of as -1, and this is +1. And I'm going to show you lining it up like this vertically, because sometimes adding multiple digit numbers, here it's not difficult, but you'll want to line them up with your 1s lined up with your 1s, your 10s with your 10s, and so on. So I did it vertically. This is showing that I'm adding 1 to the left side and 1 to the right side. And what happens when I add 1 to -1? I get a 0 pair. So really all I have now on the left is 2x. I could write +0, but that doesn't really mean anything. 2x plus 0 is the same as 2x. So I'm going to then put my equal sign, and on the right side of the equation I added 1, and I get 4. Okay, so now I have, this is my first step. Done. And that's given me a new equation. So now I'm going to go on to step 2. I have my new simpler equation, which is 2x equals 4. And step 2 says divide each side by the numerical coefficient. So you have to remember that the numerical coefficient is the number that is next to the variable, which means that number multiplied by the variable, or two groups of that number, x. So I'm going to divide each side by the numerical coefficient. Division in algebra doesn't use this thing because it looks a lot of times like a plus sign, and sometimes it looks like an x. So don't use that division symbol. You want to do a fraction. 2x divided by 2, and we have to divide this side by the numerical coefficient here, which is here. We have to divide that side by 2 as well. So this is really important here. You've got 2x divided by 2. If you look at it vertically, this makes sense. 2 halves is 1 whole. So when we undo that, multiplying by 2, you're undoing it by dividing by 2. That will get you to 1. And so your answer is then going to be x. And then 4 divided by 2, or 4 halves, is 2. So we have a solution, x equals 2. So you always want to verify your solution. Verify the solution by substitution. So I'm going to check and see if it works for my original equation. My original equation was 2x minus 1 equals 3. I'll write it down here. 2x minus 1 equals 3. And I'm going to verify the solution by substituting x equals 2. If it's true, I should be able to rewrite this, instead of with x, with brackets 2, meaning multiply 2 times 2, subtract 1 equals, oops, disappearing ink, 3. I'm going to do order of operations, do my multiplication first. 2 times 2 is 4, minus 1 equals 3. Okay, now I can simplify even further. 4 minus 1, 3 equals 3. Because the left side equals the right side when I substituted in my answer for x, that means I was correct. Okay, so here is my second example here. So take example this 3x plus 5 equals 14. What could this be? All right, so what we have to do is solve it first by following step 1, isolate the variable. We have to isolate x, but we can first work towards finding out, oops, I want it green, what 3x is. It's got plus 5 there, which is in the way. So we need to get rid of that by subtracting 5 from both sides. Or you could think of it as adding negative 5. So 3x plus 5 minus 5 on the left-hand side of the equation, and minus 5 on the right side of the equation. So why I'm doing this vertically, I could have written it out like this: 3x plus 5 minus 5 equals 14. It keeps disappearing. Oh, come back. Minus 5. The problem with that is if you have to do any borrowing when you're doing your subtracting, if you can't do it in your head, you end up having to write it off to the side. So I like to do it, so I line it up in case I do need to borrow or regroup or whatever for adding and subtracting. Okay, so I'm going to go ahead and do that. If the left side of the equation is 3x plus 5 and I take away 5, I'm left with 3x. On the right side of the equation, if I have 14 and I take away 5, I'm left with 9. Okay, that's the first step that's done. Second step is I'm going to take this simplified equation, write it down here, 3x equals 9. Now this says divide each side by the numerical coefficient. Okay, so the numerical coefficient is the number next to the variable. Here it's 3. So I'm going to divide each side by 3. And I do it fraction style. Don't use the little dot dot and a line through it. So 3x divided by 3, 3 divided by 3 is 1. So we just get x on the left side. And 9 divided by 3 is 3. So there's my answer. To finish, I need to verify it. Check. So I'm going to start with my original equation, which was 3x plus 5 equals 14. 3x, rewrite it, plus 5, oops, okay, equals 14. Maybe it's time to get a new tip on this pen. I rewrote it. Now if my answer is x equals 3, okay, I need to show that I can prove it. 3 instead of times x, put in my value for x, times 3 plus 5 equals 14. So 3 times 3 is 9, plus 5 equals 14. So you can see 9 plus 5 is 14. That equals 14. Yay, it verified, just like the last one did. Okay, if I found my answer was x equals 5, I'd plug in 5 here, and then I get 3 times 5, 15 plus 5 is 20, plus 14. I'd get not a true statement, and I'd catch an error. That's the idea of verifying. Okay, the last example. Okay, here's my third example. It's a little bit harder. You can see I have 5x minus 12 equals negative 2. I've got a negative number in here, so we have to think about integers. And hopefully it's getting to be something you can do kind of in your head. You don't need to draw out tiles. So here is my variable, 5x, x, but I've got 5 of them, and I need to try to get it by itself. So it's right now it's not isolated. Okay, so what I'm going to be doing is getting it by itself. Instead of knowing what 12 less than 5x is, I just want to know what 5x is. So I'm going to undo subtracting 12 by, wake up, by adding 12. And that's going to be drawn directly underneath. So you had negative 12 and positive 12. And over here, adding 12. So what you'll see on the left-hand side is just 5x. We've seen this in the previous two examples. This becomes canceled out, and negative 12 and positive 12 is 0. Equals, now here's something we really have to pay attention to. Negative 2 plus 12. Remember doing this with tiles? Do you remember how to add that together? What's your answer going to be? Positive or negative? Go on. What's it going to be? There you go. It's going to be positive because these two negative tiles will cancel out 2 of the positive tiles, and you'd be left with 10, positive 10. Okay. Normally I wouldn't rewrite this down but step 2, but I've done that for all of these. So 5x, and rewrite it down here, equals 10. Step 2 says divide each side by the numerical coefficient. Oops. And the numerical coefficient in each of these is the number next to the variable. So in this case, it's 5. So I'm going to divide both sides, 5x equals 10, by, oops, get rid of it. Okay, I'm going to divide both sides by 5. So 5x divided by 5 is going to be 1x, or just x, and 10 divided by 5 is going to be equal to 5. Okay, now I have to do that last step of verifying it. Pay attention to what my original equation was. 5x minus 12 equals negative 2. So I'm going to write that out. 5x minus 12 equals negative 2. And I'm going to substitute x equals 5. Instead of writing 5x, I'm going to write 5 times 5 minus 12 equals negative 2, and see if it works. 5 times 5. Whoa, hang on. I made a mistake here. Help! I can't rewind. All right. Everyone makes mistakes. X equals 2. See? Hang on a second. What would this have happened? Let's see this. I made a mistake, and now I'm catching it. This is perfect to illustrate why you want to verify. Check out my answer. 5 times 5. I said x equals 5. Minus 12 equals negative 2. 25 minus 12 is 13 equals negative 2. Does not equal negative 2. So this is how I caught my mistake. I made a simple mistake, and now because I verified, I can fix it. I can say, no, erase, scrubby. Let's do that again. It should have been x equals 2. I made a mistake. 5 times 2 minus 12 equals negative 2. 5 times 2, 10 minus 12 equals negative 2. 10 minus 12 is negative 2, and that equals negative 2. So yay, I caught my mistake. I did that on purpose, really, I promise.